Hey everyone. Hi. Hi, and have a wonderful evening. I'm so happy so many people have joined us here today. Welcome to Applifting Screw Talk. And today, or tonight rather, we'll talk about Python, as you probably know. And we can look forward to two lovely presentations. First one will be by Ondřej Doskočil, who will talk about architecture in Python. I know, architecture in Python, pretty weird. I'm not a Python person, as you can probably tell. And the second presentation will be by Stanislav from ROUVY, who will talk about his experiences, some lessons learned from his past project, rather current project. So thank you very much for being here. Enjoy the talk. Keep your questions in mind because there will be a Q&A afterwards. So, Ondra, go ahead.
Thank you. Welcome, everyone. Tonight, I want to talk to you about something I've been thinking about a lot lately, and that's architecture in Python. Why we avoid it, why that's a problem, and why I think that we are running out of excuses to use it. So let's start with something I think every developer has either seen or said. Some review comments saying this isn't Pythonic, this is too verbose, this feels like Java. I've said it myself, and I bet some of you have too. These two sentences have probably become like Python's default response to any kind of architectural pattern. And I think they're doing more damage than we realize, because when we say something like this, we're not really arguing against the idea itself, but rather we are reacting to some kind of picture in our heads, like we imagine multiple levels of abstraction, some fact stories, XML configs in Java, and that's not really what the architecture has to mean. So where does this come from? It starts with Zen of Python. You obviously probably know simple is better than complex, flat is better than nested. And these are great principles, like for scripts, prototyping, and getting things done fast. They work really well. But somewhere along the way, the community took them further and further than they were meant to go. And now we have this collective allergy to anything that looks like a structure. Like we don't use interfaces. Why would we need interfaces? This isn't Java. Why would we need things like dependency injection where we can just import it? Why would we need like a web SQL alchemy to abstract some data access where we can just like call it, right? Or for example, layered architecture. The magic word, you ain't gonna need it, but except you are, you just don't know it yet. And it's not just a culture. Our tools actively reinforce this. Like when you open, let's say, fast API tutorial, the first thing you see is HTTP router that takes the DB session, parses the request, hits the database, and returns, all in one function. SQL models go even further. It merges your API validation with your ORM. That's convenient, but it's teaching everyone to couple everything from day one. When we compare this to different ecosystems and different frameworks, such as like Nest.js and Spring Boot, the very first tutorial already separates these concerns. You got introduced to controllers, services, and repositories. And you can't skip them. The framework itself expects them. Hinek Slava calls this design pressure. Basically what it means that your tools push your design in certain direction, whether you notice it or not. And Python gives you the shortcut, but it will never tell you when you should stop taking it. But in Python, we are building real systems now, and the tutorials they haven't caught up. So what I'm actually asking for, like again, there's a typical route handler from Fast API. On the left side, you can see the HTTP business logic database, again, all in one function. Now, if you look at the right side, we have this very same feature, but it's separated into three layers. We have the top, the controller. There's just HTTP concerns. It parses the request, delegates to service, and returns. In the middle, we have the application logic, service. The service like orchestrates, it owns the transaction, talks to your repositories, calls the business rule. Notice what it doesn't do. It doesn't know anything about the HTTP, no request, no response. And finally, at the bottom, we have your domain, your business rule. It's a pure function, no session, no framework. You just give it a customer object, total, and it either returns or raises. This kind of separation is, for example, really easy to test. You just need 2 lines of code to test such domain rule. And basically what it means that it doesn't depend on your framework, on your ORM. This separation also means that it can be easily reused. You can use the same rule behind your API, behind your CLI commands, or even, I don't know, salary task. So by architecture, I don't mean like hexagonal architecture. I'm asking for some boundary where your domain can live on its own. And the reason why I care about such like small boundary is simple, because the pain shows up fast, not in theory, but in day-to-day development. When you don't have this boundary, like for example, a query changes, some unrelated workflow breaks because everything is coupled through some handlers and models. When you want to test business rules, you're starting to drag in fast API, ORMs, and database connection. And after a while, like changing code starts to rely on tribal knowledge. So people who know the system by memory can easily move, but the people who doesn't hesitates. And that's a real cost. The code still work, but it stops being easy to change. And once that happens, refactoring start to feel like rewriting. So teams keep patching instead. And none of this happens because Python is bad at scale. It happens because Python is good at letting you start without the structure. You can go from script to prototype to MVP without fighting the language. And it's generally great, but it also lets you continue without the structure long past the point where you should have added it. And nothing in the language or the frameworks usually doesn't force that conversation. So question is, where should we add the structure? My rule of thumb is like basically if you are building something that goes past the POC stage, you should give it some structure. And again, I don't mean like full hexagonal architecture, just the basics. Have service layer, repository, your domain logic separated from your framework. Another reason would be like if you are working on some project with different people, because code without structure only works like when you know it and you have it in your head. The moment the second person shows up, they need some space and they need something how they can navigate. The problem is that most people tell themselves that we will clean up later, but later never comes. POC becomes the MVP, and MVP becomes the production. So add it early, it's cheap now, and expensive later. So clean architecture in Python means domain models, as I said, services, repositories, data transfer object, mapper, separate schema. For typical feature, that's a lot more code than a flat approach. And there is also a lot of upfront work. You need to know the patterns. You need to convince your team. And you need to do all of that before you ship a single feature. More code means more concepts to learn, more time. And that is a real barrier. So what changed? AI. Now really, we have now like development tools such as Claude, Cursor, Copilot, whatever. And all that structural code that make architecture expensive, like I said, interfaces, the implementation, mappers, it's exactly the kind of repetitive work that LLMs handle well. You can easily scaffold like new services, generate your repositories from your domain models. From your domain models, and it's not just about the typing speed. When AI generates well-structured code, you start to see the patterns in action. You learn how the repository interface works just by looking at the one AI just wrote for you. So both the writing cost and the learning curve go down at the same time. So economists kind of flipped, like before AI, it's just meant more architecture, more concepts to learn, more write to code, more upfront work. And with AI, we have this repetitive code written in seconds, and you can learn yourself by seeing them in your own code base. So some practical barriers dropped significantly. But the cultural resistance is still there, I think, and that's what we need to do work on as a community. And just to be clear, I'm not saying just throw AI at it and call it a day. AI is great at implementing structure. It can help you explore your domain, your entities, suggest some spots, spot some spots, challenge your assumptions. But it shouldn't own your architecture. It doesn't know your business, your edge cases, and your users. It writes structural code, you make the design calls. And these decisions need to live somewhere where AI can follow them. So you should have some rule sets and your project scaffold. You write your architecture rules once, and AI follows them every time it generates code. So 3 things to take away. First, you need someone on the team who understands the architecture. Not to write the code, not to write the all code by your hand, but to make the design calls. AI follow patterns, but somebody has to choose the right ones. You need to adapt the patterns to Python, use abstract classes only for constructs. For contracts, you use plain data classes for your domains, leave your domain rules and domain entities from framework dependencies, use Pydantic on edges where it's messy, and the patterns from other ecosystems follows, but the code still should feel like a Python. And last but not least, encode your decisions. Use your AI rule sets, your Claude AI, and have some project scaffolds, because that's how you make sure AI follows your architecture, not by reviewing every generated line, but by giving it the right patterns up front. So architecture in Python isn't Java. It isn't over-engineering, it's engineering maturity. It's the decision to structure code, so it survives growing team, changing requirements, and production reality. The question is no longer whether architecture belongs in Python, but the question is, why are we still putting it off? Let's stop treating it like a foreign idea. Thank you.
Right, what a wonderful talk. Before I pass the microphone to you, because you might have some questions, I have one question myself. So, Ondra, next time I'm setting up a Python project, probably in Cursor, because that's my tool of choice. what would be the magical, I don't know, 2 to 3 sentences to get the right amount of architecture in?
Yeah, that's difficult. Yeah.
What would you write?
What I would write, yeah. I'm already past this phase, and I already have some preferred scaffolds and rules, everything. Basically, you need to choose the structure, like, yeah, tell it to split those in 3 layers, I don't know. Yeah, usually, even if you just say to separate it into 3 different layers, like control, services, and domain, it usually get your things done. But there is a lot of work around the like infrastructure, you know, how to set up dependency injection and stuff. That's kind of not really straightforward. So you need to have some knowledge first.
Well, I'll leave it up to Cursor then. Anyway, does anyone have any questions for Ondra? Anyone? Right.
1, 2, 3. Hi. So architecture is quite subjective often. So about subjectivity, what do you prefer, ABC or protocols?
Yeah, I'm on team ABC.
Wow. Why? Why? Can you explain?
I don't know. I just like that it's like enforced by default. Like for protocols, you need to have like external tools, like type checker, to properly use it and like check that your protocol actually correct. Yeah, that's probably the main reason for me.
Okay. Then another question then. So do you prefer inheritance or composition?
Depends. Probably composition.
Okay. Thanks. Nice. Why?
Yeah. I know. Just. I don't know if exact reason. It's just my preference. Like you said, it's subjective. I prefer it. Sorry?
No, it's correct.
Yeah. That's also.
Why is it correct, though? Because that's a complicated question. that takes a lot of time to answer.
Yeah, I don't know. I wouldn't want to say like this one is correct and this one not, because like, yeah, you can't say that.
No worries. No, it's a joke.
Any other questions? Anyone? Does not seem like it. In that case, Ondra, thank you again for the talk. That was quite lovely. And okay, so we need to wire up the next speaker. So, what can I tell you in the meantime? So I have a small daughter, like not this small. She's like a year old, and she knows only a few words. She already knows Python because she has this book about animals, and there is a snake. So obviously, snake is a that's Python. She doesn't know how to program, so she would probably just like smash the keyboard and, I don't know, write a Perl script. Does anyone here know Perl? Anyone? No? Good.
Some people in their late 60s.
Does anyone know about some Python jokes? Are there any Python jokes, actually? Like, obviously, as I'm not a Python person, I make fun of Python a lot. Anyway, let's give the word to Stanislav. Go ahead.
Do you hear me? Yes. Okay, so, hi, my name is Stanislav Gurník, and I work for ROUVY company as a backend lead. For you that don't know the ROUVY, we are the application or some kind of game where you put your bicycle in front of the screen and we allow you to ride your ride your bicycle anywhere in the world. So if you're a cyclist, I strongly encourage you to try us. So as you can imagine, our backends are quite complicated nowadays. When I started at ROUVY, there were only 3 backend services, 2 PHP monoliths and 1 Python service. And now we operate 80 services in our backend services in our infrastructure, and majority of them are Python services. So I want to tell you some like crash stories from our journey that we learned. To fully understand our challenges at ROUVY, I need to little bit briefly introduce you to our infrastructure. So we heavily depend on the Google's ecosystem, and all our services, or majority of our services, are run on the cloud runs that are several solutions by the Google. There are some specifics that I will talk about later. One of them is that those applications are obviously stateless, and also they are not very good at running long. And another major thing in our infrastructure is that our infrastructure is largely driven by the events, or the queue that is running the events. In this case, we use Google's proprietary solution called PubSub, but basically works similarly to any messaging system like Kafka and so on. So the fuck-ups. The startup crash, basically this is around the migrations. As probably some of you, we started with the simple solution. So in every container run, the container itself, before it started to respond, it checked if there is any migration, and if there was, it ran the migration, and then the container startups, and everything was fine. This was simple, quite effective solution for the first several 100,000 of rows. But after our databases grow to several hundred or millions of rows, this becomes quite challenging, because the migration just ran too long for the container to really catch up to response. So basically, every time we try to run the migration, the container goes out. It failed on the migration. Then the Cloud Run spin ups another container, and so on, and slowly basically kills the production. So nowadays, we run migration in our CI/CD pipeline, and we have one rule, which there cannot be any breaking migration. So every time we try to, rename the column, we don't do that. We just create new column, migrate the data, deploy the new container with the new application, and then delete the old one. So this is what works for us now, and we are able to run migration through quite large databases, we think. And I told you about that Cloud Runs are not very good at running long jobs. This is very, very, very true. Basically, there is a hard limit on running one job for 1 hour, but since we are using the PubSub, and we cannot use full subscriptions, because that requires the application is running for whatever you need to do, we rely on the push subscription, which works a little bit differently, where the push subscription basically creates a HTTP request on your application where the payload is your message. And there is another limit, which is like 600 seconds, which is quite not a lot for when you need to process large payloads of data. So we need to figure out how to go over it. And there are two processes that we can do nowadays. If this task can be, we split this task. This is the first step we do. And the second question is if we are able to process it asynchronously. We basically create a message for each chunk of the job, publish it, and let the backends to handle it. There is maybe one note that I want to add, that we usually have two deployments of the same container. One is for the client's traffic. There is basically unlimited scaling, and the second one is just purely for PubSub. We do it for the traffic throttling. So in the case that large amount of events came to our infrastructure, we slow down the processing so our infrastructure isn't killed. So this is the one pattern. The second solution is something I think maybe called as the pointer pattern, where every chunk that is created basically publish the message to itself with the pointer where it ends, and second job will continue on this pointer, and so on and so on, so on until the job is finished. Some kind of relay race when the one rider gives the ballon to the another until the finish. And this finds very predictable and cheap solution for us. And we like to, at ROUVY, we like to have things simple as possible. Since we are here in era of AI and various hacking solutions, we need to take security as a priority. So for us, the IAM, if the solution is one of the solution, this is about that the application doesn't have any secrets. It's just fetch the access token and use this access token to access any resource that it needs. In this case, our databases. And the recommendation for this was to use the manage pool for creating the connection to the database. So you have manage pool, which handles all the connections to the database. But we saw that in our Python services there was quite long delay, or if we implement it, that our Python services suffer in performance. So in this case, we switch from manage pool to application pool, which works a little bit differently. It's maybe a little more complex to implementation, but the access token is fetched only one and used for the whole pool. Okay, maybe I step back a little bit. The problem was that for every connection, the access token needs to be recreated again. So every connection was with 200 millisecond toll booth. So it took a little bit too long for us, or rather say, very long. And of course, if we have ATS services, not all of them are Python, and also our developers are persons, so they have different preferences. This leads to quite a mess in our logs. Behind me, you can see all the versions that basically describes one information, that is user ID. And when we want to try to triangulate some problem, this is what we were dealing with until we created the specific Python Node.js and .NET application that normalizes our logs to one single format, and it does this automatically. This is image of our events architecture. As you can see, that is quite vast, but having the event-driven architecture without proper tracing is, I don't recommend it. It's like having black box where one event occurs at one end and reoccurs somewhere else without like knowing what is caused, what it happens. So again, our solution is we are using Datadog for that, but that doesn't matter. What matters the most is that we created the package, Python package, which transparently gives the pub/sub message the trace attributes and then extract them from the attributes and continues the span. So we have always the whole picture of what event actually caused in our infrastructure, which is very valuable information for us currently. And with that, with event-driven architecture, there's also always the problem with documenting the events. We have hundreds of topics and another hundreds of subscriptions that subscribe on these events. So we were solving this issue for quite a long time. We knew that there was existing async API format, which is quite young, and no formatter in place that we can use. So thankfully, Ondřej here created a solution for us where basically we use LLMs to generate and keep our async APIs at work and in sync. And for the actual viewing and the documentation, we use Event Catalog. And again, thankfully, it provides MCP server. So we are able to check when we made some breaking changes in our payloads. It will automatically check each service that is subscribed to the topic if this change will introduce any breaking change or not. And last thing I want to talk about is that when I started the programming, there was like the running joke. I think it is still up to date that there are only two problems. One is naming, which is still a problem, and the second one is caching. So at ROUVY, from the time when I arrived, we came from the state where we were not caching at all to caching practically chaotically everything that was underperforming to solution we use today, which is that we have BFF, which is backend for frontend. So this is backend service that sits before our client. It basically aggregates all the data. It's a responsibility to cache everything. The client needs it frequently. Also, of course, it is subscribed to all the changes and invalidates the cache. Until there was, and our services backend have very little or no cache behind them. That was until one of our third-party providers, after two years of non-stop running, fell down or stopped working. So our infrastructure was not working properly. So from that day, we also implemented the caching there, and also we have dedicated services that basically work as the caching layer, such as the leaderboards and so on. So that will be all from my side. Thank you all for the attention. And of course, if you have any questions and you are interested in something specific, I'm here to talk.
Lovely. Lovely talk. Thank you very much. I think that some of those examples is something I can learn from as well, even though I don't use Python myself. So thank you for sharing. Are there any questions in the room? Anyone?
Great presentation, by the way.
Thank you.
I love the topic, like how topical it was. I want to ask how long about are the migrations running? Because it sounds like that could be running for a while.
Depends. The longest can run up to hours. But the main point here is that make the migration like non-blocking, because obviously you can like kill the database with the migration. So there are some consideration there.
Do you remember any weird hacks that you had to do to, keep your database running? Were there any?
Yeah. Yeah. Well, there was some fun session with my colleague Martin when we ran the migrations, and obviously it kills them, and you cannot kill migration in the middle of that, because you would take the database to inconsistent state. So taking the last valuable backup and migrate it in the database while the database was still running was really fun.
Thank you.
Any other questions? Anyone?
How do you deal with rollbacks then?
Sorry?
How do you deal with rollbacks?
Rollbacks. Do you specifically mean the migrations, or?
Of course.
Yeah. Well, currently we don't do any.
Okay.
Thank you. Reminds me of this painting course I was in, and there was a question like, what do you do if you make mistake? And the answer was, don't make mistakes. So any other questions, anyone? Does not seem like it. In that case, thank you very much again for a wonderful presentation. We'll have a brief pause, so get some refreshments, get something to eat, and we will be here in about 10 minutes. We'll put some chairs here, and we'll have a panel discussion you can look forward to. And there is a QR code where you can find Slido, so you can ask your own questions you will be interested in. So there are really interesting people talking here today on the panel. So go ahead, ask about anything, and if there won't be enough questions, I have some myself. So have a nice pause. So it seems that our guests are now seated. So I would like you to welcome our wonderful panelists for tonight, which are Ondra, who you already know from the talk, Stanislav, who we already know from the talk, and then we have Jirka from DX Heroes, and Martin also from ROUVY. So thank you for being here with us tonight. And as I mentioned, that Slido, I see that there's currently one question there, and I've prepared some lovely questions as well, so we'll start with one of those. So, gentlemen, enlighten me as someone who obviously doesn't use Python too much. When you use a different language, what do you miss about Python? Yeah, sorry, I you have to unmute it.
On three. I don't know. I come from the embedded world where there's a lot of C and C++, so there is, it's a large downgrade in terms of many creature comforts, let's say. I don't know. I like the general ease of giving stuff structure. Like Ondra mentioned, you can go without it, but if you want to add it, it's not that difficult since the language is just made to be quite simple. So it doesn't fight you that much. And I think things like, I don't know, list comprehensions and stuff are like pretty useful for quickly expressing quite difficult things that, may be a lot more difficult in different languages.
I must say that I miss the simplicity of Python, and that is something that Ondra talked about, and I quite strongly disagreed with him. That when you are prototyping something or doing some one-time migration script, which we never roll back ever, it's quite nice to have the opportunity to just express your minds in the simple words without any interfaces and repositories and stuff like that.
Thank you. Guys?
I don't really use other languages. I like that the Python is simple. I really like the REPL, the Python shell is really great. Like especially in my Django days, I could just easily connect to production database on the server and just execute stuff. That was nice.
Thank you.
So I'm also not very Python guy myself. I'm considered more a TypeScript guy. But what I really like on the Python is that name arguments. I know it is not like the Python specific thing, but I really like the simplicity and the implementation in the Python, and solely the fact that arguments may not have the order, such as in Node. I know that this can be implemented with the DTOs, but still the Python is more clean implementation for me.
Thank you. Very glad I got you talking. So now, as we started, I would like to pass the word to Jirka and then to Martin. And if you can briefly introduce yourself, because the audience already knows Ondra and Stanislav, that would be really nice.
Yeah, so I'm Jiří Maňák, and currently I work in DX Heroes. I've been here for a year and a half, and we specialize in developer experience, and lately we've been working on AI implementation and automations there, since it's closely related nowadays. And yeah, I work on a project for an American startup. and it's written in Python, and it's quite large, so I can share some pitfalls we've run into in terms of scale and stuff. But that's for later.
Lovely.
My name is Martin, and I work at ROUVY for many, many years. Once upon a time, we had just one monolith of PHP, and the years are now gone. And I'm working as a DevOps engineer. I'm developing mostly in Python, but I had to take some jobs in C# or in TypeScript, which I quite hate. So we like to somehow fight with Stano time to time.
Lovely. So as we have introduction and the first question behind us, it's time to get something more juicy. And one thing I really missed in Python in the past was threading, of course. And right now you can turn off the GIL and do some free threading. So my question is, do you guys use free threading, especially in production? And what's changed for you since then? Would anyone like to answer that, share some experiences?
You won't like it because I don't use free threading in production. Yeah, no, yeah, I don't use it. Like for me personally, I think not many things will happen because I almost always do like basic like backend systems which are async, so single threaded, and I don't do any like computational stuff usually. So I don't think that something will necessarily change for me personally. I think there will be a lot of work like in the underlying frameworks and the tool we use. Yeah, but for me personally, probably nothing will happen. I think.
I will join Ondra. I also do not use threading myself. I'm quite comfortable with the event loop. So basically, we have to use the threading in ROUVY. We do it in other languages than Python, and we are happy with that.
I'll join the no threading or free threading in production crowd, but it's been quite a while since I built a little script for analyzing a bunch of stream data from like a serial connection, and it was quite important to like debug what was happening there. So I added on FFT, I added on a pyplot, and suddenly it was, I think, 5 years ago, I ran into the complete lookup of the main thread there, and it was clear the application was struggling extremely badly there. And I would be really interested. I haven't tried running this particular script, because it was like one of those debugging things that you just throw together, and that's what Python is really great at. I have to try running it under 3.14. I think it would improve quite a bit. So I agree that for IO-bound applications, async await is the way to go, but I think there will be many like improvements which are less, mainstream in this regard.
Thank you.
I would like to say yes, but unfortunately no. We use some multiprocessing capabilities of Python, but in fact in few months back we had to do some computation of or simulation of riders passing through our routes using GPS coordinates, and I did some implementation in Python. One round took around 1 second, but there was some discussion, and we decided to move it away to C# or .NET, and after some optimizations, one round was done in 2 milliseconds. So I must say that the threading model of .NET or C# is quite more capable than in Python. Maybe we could somehow improve it, but I'm afraid that Python is not the best tool for this kind of work.
Thank you. So just show of hands, is there anyone in the room who uses free threading in production? Anyone? No? Okay. Maybe we could make some I Love Gil t-shirts or hats. Anyway, I'll continue with a question from Slido, which is, this might be especially interesting to Ondra. What are your favorite architectural patterns in Python? And yeah, go ahead, go first, but I would like to know the answer from everyone.
Like, I'm wondering what, like, the architectural patterns aren't necessarily tied to Python, right? So, like, what are my favorite architectural patterns in Python?
I mean, it could be
Okay.
interpreted as any architectural patterns. We could fall back to my question, like, what architectural patterns do I give to the cursor to?
Yeah, definitely clear architecture is way to go. Use strategy pattern, I don't know, adapter pattern, stuff like that. But those aren't like necessarily in Python. You just need to build them yourself.
Okay. Any other favorite patterns? Anyone? Maybe not. We'll move on. So next question from Slido is, has it ever happened to you that Python was too slow for the task and you were unable to solve the issue and had to choose a different language? As Jirka was working with C, maybe?
Yes.
Yeah? Okay, Martin. Would you like to elaborate?
No. It was the story I told before, that moving to C# was really best option.
Anyone else?
I was crazy enough to like work on the byte level from like streaming data over USB and stuff, and that's clearly something that Python wasn't built for. I started to notice that when I had to use something like sleep for a fraction of a millisecond to like unblock the that ties back into the free threaded discussion, since with the GIL everything is kind of implicitly locked and mutex, so there's a lot of latency connected with that, and obviously using Python for something like that isn't the right choice. But writing bindings into C++ was extremely simple, since there are established libraries for that, and once that's done, then it's quite simple, and Python works with much bigger chunks of data, and you get the best of both worlds. So yeah, working with like, I think of Python as a front end for like compiled libraries in some sense, where you have the advantage of real quick prototyping. We're using extremely large frameworks like PyTorch or something, which otherwise, if you were building them from source, you'd spend a lot of time like just building them and not iterating. So using Python and the bindings is great for that.
Okay, thank you, Irko.
I don't think that Python is like the fastest in anything. It was always like one of the slowest kids in the block. Except one exception we have in ROUVY, that we use ClickHouse for our time series databases, and there, like the native adapter for the ClickHouse was far more superior than any other language. And this is the case that clearly Python apart from any other language?
It was more than 10 times, and I was very happy that we didn't use TypeScript for that.
It's funny, this thing. Python is like slow on paper, and in principle, when you look at how it works, it should be slow, right? It's interpreted, but because there is such a large community behind it, things just get optimized for it, and that's the same for the ML frameworks, right? They are ginormous and like slow in principle because they pipe a lot of data around, but the Python interfaces are the best.
Sure, but I think like the strongest part of the Python is simplicity.
Yeah.
Like not the speed.
Yeah, but I guess the just pure, I don't know, the like rational thing that interpreted language is slower, negates the amount of effort you put into it, kind of like, or balances out this.
Yeah, don't mean like bad. I think like guys did a great job with the Python, but still.
Okay.
One, if I can, we have a use case where we have to process videos, a lot of videos, and for that the Python is excellent because the processing of it is quite complicated. You need to decode it, then use some algorithm, make some anonymization of the faces and signs, etc. And you have to connect somehow all these tools. And the fact is that in our company there are quite a lot of people, and they are not programmers, but they can use these tools extremely well. So they were able in Python to connect them, like taking the FFmpeg for encoding the videos and playing with all the millions and millions of options which the FFmpeg binary has. And the output was that we have the processing pipeline in Python, which is working really great, and all the heavy computation is done in different languages, and this allows us to produce the output quite fast. Unfortunately, the drawback was that the people which are not programmers produce the code which is really bad, and it's 2 years and we still don't make it quite nice. 3 years?
Even some people who are programmers can produce some pretty bad code, so it's not unique to non-programmers. However, before we go on to the next question from Slido, I have a practical one. We have Python 3.15 ahead of us. What is your strategy to migrating your projects to the new Python? Like, when are you going to do it? No. How are you going to do it? Are you going to do it?
No.
Could you elaborate?
No, I'm joking. We had experience, I think that it was 2 weeks ago, maybe 3 weeks, where we wanted to take pace with the board and update one of our services to Python 3.13, and everything looks great except the performance. And we suddenly see that the latency increased almost 2 times. We had no idea what's going on. We tried to put some Datadog profiler on, and it wasn't successful. So we decided, what we can do. So, well, the solution was going back to Python 3.13, and the problems were gone. We didn't investigate the issue, what was the root cause, but just downgrading solved our assist. So it was it was the lesson that we are not going too hurry with the updating.
Yeah, I think like performance tests are really a good start. Like how to check if you want to upgrade to newest Python. So yeah, definitely do some performance testing. Probably not in production. You can and maybe you can test it like in some play with it in some like internal tools and yeah, explore how it's performing.
Mm-hmm.
I may say that our strategy at ROUVY is that our always new projects are usually started with the latest we can get on. So the latest Python, latest packages, latest everything. And then we will just push from it. If we validate that it works and we learn from the new features, then we will usually deploy.
I try to play around with it. I wrote Python, which was like a weekly project, or I guess a blog post about the latest in Python. And as part of that, I experimented with new features and tried to validate them. So I think that's one way to validate, but you have to have time for playing around with it and writing some like toy projects. Of course, I think the biggest blocker are the dependencies, and especially the compiled ones. And it takes a while for them to catch up when a new version is up. And from reading the changelogs for the recent versions, the major bumps, the initial release was quite bumpy. And I think they yanked even the 3.14.1 or some release like that. So I would be interested in you guys exploring the reason for the performance regression, because I heard it when we were last week, and I tried to dig up some like other examples of this, like people posting about the issue, and I couldn't find one. So could have been something very specific.
I promise we will investigate. I will give Martin 1 hour for that.
Okay, maybe a connected question. I saw that in Python 3.15 there'll be support for lazy imports, which might improve performance, right? Like startup times and yeah. So would that be something you would be interested in exploring? Because it seems like a useful feature, to be honest.
I hate when cursor decides to create lazy imports in code because it's too lazy to put them up there. I think it's the contrary. I think it can cause performance issues if you don't catch these things. Because if you run into some code path that runs into a module import that's quite heavy, then suddenly you have a latency spike, and lazy imports will basically codify this and make it almost like a default of some sort. So I think it's a cool feature for like CLI tools and stuff where startup matters, but for backend where if it starts up a second later, it probably doesn't matter. Mm-hmm. I would be very cautious of using it, or at least like using it where it makes sense.
Yeah, completely makes sense.
I'm really excited about lazy imports. Like for example, like for CLI, it's such a pain. Like when you run like help, and it's just like you wait multiple seconds just to see the help of some CLI tool. It's so like frustrating. And yeah, lazy imports will definitely solve this. And yeah, also as mentioned, like lazy imports in the middle of file is not great.
I mean, every tool can be abused, so yeah. Anyway, sorry, go ahead.
I would like to add something because I'm very smart and I had to talk some and say something. I just wanted to add that we are using the Docker images running fast APIs, which is a framework using for HTTP requests. and I believe that there it could help in decreasing the latencies on startups. So there, I think that it could help, because we have services where we use pandas or numpy for some specific endpoints, but they are not used very often. So I believe that it could help, but I'm somehow skeptic because every time we tried to solve some of our performance issues with increasing the Python or database versions, which were promising the immediate increase, it didn't work for us. So I hope this will be working, but I'm a little bit skeptical.
Thank you, Martin. Okay, let's move on to the next question from Slido, which is, how do you feel about functional style code in Python? Have you ever used functional style code in Python, or is it a sin? I haven't seen functional style in Python.
Yeah. Me neither. I don't know. I don't think like Python is really suitable. I don't even know if you can like actually achieve like functional programming. You can do it like in Rust or something. It's like really great, but yeah, not in Python.
Okay. Thoughts? Okay. Lovely. My next question is something that's close to my heart, and that's, how do you work with, let's say, dependency safety and like supply chain safety in Python? Because like recently we've seen some supply chain attacks, and maybe we can expect some more in the future. So what do you think about it, and how are you planning how are you planning on defending yourself against them?
I think it's much easier than ever to do a code level audit of your dependencies. If you bump quite frequently, then the code diff is not that large, hopefully, and AI can help with that. I tried some like real quick writing a real quick script which would pull both the versions from PyPy and diff them locally, and then run like sub-agents in Cursor to audit them. I think it's not perfect, but it's becoming a lot more feasible, and it wouldn't, cost a lot of like manpower to implement something like that if you really care about it.
That sounds like a really, really responsible approach. Is there anyone in the room who does this? Sorry? Yeah, freeze your dependencies. Always a great idea. Yeah, thank you. Any other ideas?
Yeah, basically use some proper package manager like ROUVY, which is like log files and has hashes of the specific dependencies in the log file. And like minimum you can do for like supply chain index is like also having some minimum age of package you can download. You can, I think all of like Poetry and ROUVY both support like abilities to pin like what's the minimum age of your dependencies you can actually download. So, and if you set it like reasonably, usually you're pretty covered, kinda.
Mm-hmm. What's a reasonable time? A day? A week?
Yeah, like week. Yeah, I think a week. Like usually, like these issues are solved like in hours, let's say, and pretty fast. But yeah, 7 days might be. And obviously, like don't update dependencies.
And we can do this?
Yeah.
Lovely. Mm.
It's called exclude new or something like that. Yeah.
I'm dumping pip.
Yeah, dump pip.
Okay, so we have a strategy for that in ROUVY, that we use some proprietary solution from the Google and the Google Security Center. Basically, they have like list of trusted open source software that works in the way that you don't use like the pip registry for the Python packages, but you use the Google's registry, and it basically acts as a proxy. And what they do, they allow you to install any package, but you can see in the security center that which packages are considered malicious in some way, and also they notify you if any package that they detect was somehow attacked by the attacker. So we depend on that quite heavily. And I think it's a great solution, and they also have a free tier, so I encourage you to use it. And they support like ton of open source packages.
That sounds really lovely, because then when you get attacked through a dependency, you know that at least Google has the issue as well. So. No, that's really a great idea. Thank you. Okay, Martin, is there anything you would like to add, or?
I thought that this kind of attack is possible only in TypeScript. No?
No, it's usual in TypeScript.
Okay. No, Google has something like, I think, 1,500 of libraries there, and the rest of it is downloaded from the sources. So you are somehow safe, but as well, Google doesn't have the base Python images for Docker, so there could be also the surface for the attack. So it's not bulletproof, but at least we can see it in the security command center which we are using.
Lovely.
And it's also useful to have some like kind of tools around your like, for example, in pipeline that will like check your dependencies and actually like tell you, hey, you are vulnerable, and so have some kind of software or bill or something. Yeah, there are tools for that.
For this, we also start to use Dependabot from GitHub, which somehow help us with this issue.
So let's look at one more Slido question, which is really specific. Does it make sense to use Python for web apps? And why would you decide to use Python instead of .NET? Is one of the factors the size of the app? Does any one of you have experience with .NET? Okay, then go ahead.
I think that is a good idea to use Python for web app.
You do, so.
Yeah. I don't have experience with .NET, so I can't really tell. I'm not sure if, I don't think that the size of application decides like what kind of language you need to use. I think that Python can handle well like scale, so yeah.
Okay. Anyone else? Any ideas?
Simplicity. Again, Python is great for that, so.
I really don't like the size of Docker images that are associated with Python, since all the dependencies are quite large, and it's a real difference when compared to like.
Have you seen TypeScript?
Yeah, sure. There's always something worse, but then you have the entire busybox and 150 executable programs in like 3 megabytes, right? In Alpine OS, so it can get a lot better.
If I can add, we are trying to use the slim versions of Docker images, which is not so slim as the Alpine, but you don't have to mess with all the Python dependencies. And we are switching now from one-stage build to multi-stage build. And effectively, it shows something like 30% decrease of the Python images, so it's quite a big change.
I tried this where you delete the original source files and only keep the compiled bytecode, but then it broke, compiled, like, I don't know, there's the sync PG library, which broke by deleting the original files and stuff like that. So you introduce, like, by directly affecting the way the packages are stored, you could introduce some regressions. Yeah, it's real difficult to get the image size down to something like under 100 megabytes if you care about that, but usually people don't, so it's not an issue.
Yeah, but in our case we do, because like the Cloud Run scales only that quickly how is possible to download the image and run the container. So for us, the size of the container or the Docker image and the startup time of the application is really, really important.
And how large are your images if you use heavy dependencies like pandas and stuff? I'd imagine they could be quite big.
They are.
Yeah.
They are. But the fact that we can like lower the 40% is critical for us. In fact, that.
Lovely. Thanks for all the inputs. Yeah, I think we failed to mention that I remember from like 10 years ago when I started with web apps, or maybe 15 years ago, and I wrote in .NET, it had excellent support for SOAP APIs, which is also really important. Anyway, let's move on to the next question. And this one might be up to date for some of our listeners. What kind of AI tools do you use right now in your tool chain? And which have you tried, which you like? And what can you recommend? Like if someone is doing things old school, no AI, what should they try?
Yeah, currently I'm on the Cloud Code side, but like when I tried, I was like, when I started using AI, I was kind of pragmatic. I'm still am, but I tried like Cursor, which I had like extension to PyCharm, and just basically autocomplete. And the more you let AI go do more stuff, then you change kind of tools. Like you can go from Copilot to Cursor, and if you just want to like AI spit code out, just use Cloud Code. I think that's like yeah, really nice, really great tool right now. And yeah.
If we are talking about Cloud Code, we need to ask which model.
Yeah, a model. Okay, yeah. Opus 4.6, I think.
Okay.
Yeah, it's the great one. 4.7 is garbage. Yeah.
It's pretty expensive, isn't it?
Yeah, exactly. And
Anyway.
also the outputs aren't that great.
I think Cursor is, you asked which one would I recommend for someone who's new to this. I think Cursor is the easiest to pick up because it's familiar for people who use VS Code. And I think it's really good in the way it's able to orient itself in an existing code base without any prior setup. Mm-hmm. Like it maps it out, it understands it very quickly. And if you're new to AI-assisted coding, then you probably want to have insight into what the tool is doing. And I think Cloud Code really tries to hide this from you. It doesn't show all the steps that it took, but Cursor lets you, inspect everything that the AI did, and it provides the trace for it somehow in like a convenient UI that makes sense, in my opinion. Mm-hmm. But I think there are different tools for different jobs, and as Ondřej said, Cloud Code is really good at just spitting out code, and it's usually mostly correct.
I hope that's sufficient.
For myself, every tool that I can touch my hands on, but lately I'm more a Cursor team, but with the Cloud Code extension. And again, I will repeat myself, but I really like how they are managing the workflow with working with the AI agents. And for the guy who never writes everything manually, I just start with anything.
Right. Martin?
I think last few months, I also prefer Cursor, but I must say that I am using the Opus 4.7, and I must say it's quite wonderful at least for my experience. Anyway, as I said, I think that there are quite useful tools for different jobs. And for example, we use GitHub and its Copilot, which we are using it for the code reviews. And many times it's quite a mess, and I just click it out and ignore the things. But I think that maybe it's getting better. But now around 50% of its comments, it's really useful, and the combination of multiple models gives the best results. And from the, few weeks back, I have read some article which recommends to let the AI first create the plan, and then find weakest points, and then ask additional questions. And I must say that it was really a deal breaker, because from the asked questions, you can directly see how bad the AI is about the output, or how bad you are in the prompting it. It depends. I like the first version more, but I think that this is really helping using the tool as you want that. Right from the beginning, before the implementing any code, you can see what it is going to do and which weak points it can find.
This is a great point. I found that right after it executes the plan, I like to ask it which other decisions that weren't captured in the original plan it had to make in order to implement it. And it usually comes up with certain design decisions, or sometimes it's stuff that you would miss otherwise, where it found a piece of code that it didn't read before while during creating the plan, and had to rethink the whole thing. But it won't tell you in the final summary. So asking it this direct question prompts it into like reflection of some sort, and it will surface stuff that you would have to find manually otherwise. So yeah, I think improving the prompting techniques is an interesting discipline, to say the least.
Mm-hmm. Did any one of you ever used the multi-agent approach, like having a team of agents that work together on the task?
I think you lose control quickly. That it's like, I think it's useful for some really quick prototyping where you don't care about the quality, to say that. But if you're I like to think about this in the way that I'm still responsible for the output, and I can't throw my hands into the air and say, yeah, AI wrote it, I don't know what it does, right? People are going to ask why certain things were implemented the way they were, so yeah.
I only used it because Cloud Code, both Cloud Code and Cursor already kind of does that, for let's say exploring your code base, it spawns multiple agents, so that's kind of agenting team. But yeah, apart from that, not really. Yeah, I just assume Cloud Code will do it for me, and so that I don't have to think about it.
Tried it for the personal project, and I find it kind of works, but only those boundaries are really, really tight for the agents, and their job is really small and very, very specific. Then it works quite well.
I must say that from my experience that when I see that the AI is working more than something like 10 to 30 minutes, I stop it immediately, because the output is usually just a mess. and I'm trying to split the prompt to multi-prompts or specify the prompt somehow else, because usually when it takes just few minutes, the response and output is quite reasonable.
So wait until your budget is like gone, and then you start prompting it.
Actually, I try to look for tasks that have feedback loops in them. And I try to increase the time where AI is standalone and can iterate on its own and check its output. So I think I had GPT-5.4 run for about an hour, debugging some problem. We had a regression in the backend. It exhausted all database connections. And so there was clearly some leak, subsession leak there, but I didn't know where it was. So I said, I told it to instrument the backend, to implement the tools, the observability tools for it to find this, and then to replicate the issue and write performance tests so it won't happen again. And it worked on it, and it ran its test suite, and it added like 2,000 lines of code, but they were all instrumentation that could be removed later. And it actually did find the regression after all the time, because it was able to check its output. It wasn't guessing. It was iterating. It was running like a human would, but I didn't have to supervise it. So I think finding these things where the AI is able to be in a feedback loop, it's not perfect, but it's able to correct its mistakes if given the opportunity and the right environment. And it's definitely not always possible, but when it is, the time saver is amazing.
That's a really lovely example. Thank you. I'll look if there are any more questions from Slido. There's one. Do you have any code publicly available that you would consider a good resource? And I'm not sure how the question is meant. If Mike is here, maybe he can elaborate. Oh, perfect, lovely. Mike, go ahead.
A good resource for learning more about the things that you talked about.
And do they have to be the authors, or?
Well, they don't really, but it's better if they were.
Okay.
There's a really great book. It's called Architecture Patterns in Python. I don't remember the author, and it's, I think, freely available online. So it's like really nice introduction to architecture, both introduction and like domain-driven design. And yeah, it shows you a lot of patterns, and I think you can learn a lot from it.
My recommendation would be to look at the other languages. I think Ondřej was like, his talk was on point on this, that other languages are quite somewhere else than the Python in some ways. And well, I always learn by doing, and I mostly learn from the other languages where the new ideas, how to approach things, appear from me personally.
I actually do agree with this. I really like playing with Rust because it's a modern language and it does a lot of things well. And I found myself applying some of those like thinking principles, because in order to write Rust, you have to think a little differently than in other languages, I think. Or it's the functional paradigm, or at least it's leaning closer to that. But it could be applied to Python in similar ways. Also, one interesting resource is reading the Python interpreter. If it's fully like open source, and the documentation for it is really amazing. It goes into technical depth, but also it's really well written, and it's quite easy to read, even though it's quite complicated. And it's one of those code bases that's really like, babied, if that's, because there are a lot of eyes on it. and it moves quite slowly. It's quite technical. You won't really learn, I guess, about frameworks and stuff, but you will learn how Python works internally, and that can inform some decisions you may do in the code.
I like network or a computer guy, so for me it was a really nice, different view when I was reading the site reliability engineering books from Google, because there is described how Google thinks about operating services in planet scale, and how they manage all the things, and at which metrics they are looking, how they are structuring logs, and the insight from the operatives was for me really excellent. And I must agree with Stano that programming in multiple languages gives a really different view on in which Python is a very great tool and in which it has some drawbacks, and you suddenly know which tool to use for something you need to do.
Okay, thank you. And before we get to my last question, there's one more question on the Slido, which is voted as most popular, so obviously it's important. Do you like snakes or spiders more? Snakes? Hands up. Spiders?
Yes, I hate snakes. I'm really terrified of them.
Do you hate snakes so much you would consider liking spiders?
Yes, I'm also afraid of heights, so I like rock climbing and paragliding.
I mean, being afraid of heights sounds like just like being a person and being reasonable. Anyway, my last question for you is, imagine there's like few years pass, let's say 2029, and society is still here. Python is faster, Python has solved dependencies, Python has free threading that someone actually uses. What will Python people complain about? Like, what's missing in Python then?
Expressive type system. I don't know. I think that's going to be really hard to fix, but otherwise, I don't know. I don't have much to complain now that the dependencies and UV work. It's a lot of the pain that was caused by that is gone now. So.
Mm-hmm. Thank you.
Yeah, I agree with type system. Also, I would really like be able to ship my application as a single executable binary, and like without using like some Py installers, Noitica, like external stuff which like does like workarounds and transcompiling. So I would really like single executable binary which is like can easily be built by the language itself.
Mm-hmm. Interesting.
Maybe you have noticed I'm not a big fan of TypeScript, but what made me really wow was the conditional chaining. When you have, I hope I used the correct term. When you have a nested object in Python, you have to do if something is not none, and another if this sub-object is not none, and then if this value is not true. And in TypeScript, you have name of the subject, question mark, dot, name of the sub-object, question mark. That's really great. I really love this.
Yeah, that's really sexy. I love that about Swift. I use Swift a lot, and it's lovely. Stand up?
Can I answer as a TypeScript guy? Because Ondřej, again, thank you for the presentation, but for me, the culture will. This is something that I quite don't like about the Python, and I don't think it will change in 2029-ish and something. It's like the Python is, how to say it, conservative. Is the word, and like the TypeScript is on the other end of the scale, so it's not conservative at all, and I would like to see the Python like somewhere in between the Python and the Node.js on current state. So I wish all the Python guys here to be like the more open.
Lovely. So thank you. Are there any closing thoughts you would like to share? Anything at all? Well, in that case, thank you very much for being here. Thank you for wonderful questions from you, the audience. And we will start with the networking part, where you can talk about Python, talk about anything else, share some stories like why you don't use free threading. And yeah, thank you very much for being here tonight.